Hello everyone, welcome back to my channel. My name is Antonio G. Tolosa. So for this day, we will do the all activity in chapter 6. But before that, we need to read the introduction of the chapter 6, which is the network layer. So network application and services on one end devices can be communicate with application and service running on another end devices. How is this data communicated across the network in an efficient way? The protocol of the OSI model network layer specifies addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enables data to be passed to a destination within a network or on another network with minimum overhead. So this chapter focuses on the role of the network layer. It examines how it is divided network into groups of hosts to manage the flow of data packet within a network. It also covered how communication between network is facilitated. This communication between network is called routing. So we go to the activity in chapter 6. Okay, we go to topic 6.1 and find the activity here. Okay, okay, this. So the title is IP characteristics. IP the instruction is read each IP characteristic, then click connection, best effort or media independent to indicate its delivered method. So that's not guaranteed that the packet will be delivered fully without errors. So I think it is best effort. Then no contact is made with the destination host before sending a packet. So it is connection less. Then will send a packet even if this destination host is not able to receive it. Connection less. Then will adjust the size of the packet sent depending on the type of network access will be used. Media independent. Fiber optic cabling, satellite, and wireless can all be used to route the same packet. Media, media independent. Then packet delivery is not guaranteed. I think this best effort. Okay, it's correct. So we are done in this activity. So we need to find another activity here. Okay, this. So the title of this activity is IP version for header field. So the instruction is read each IP version for header function and then click the IP version for header field to which it belongs. So identifies the upper protocol to be used next. Oh my god. Use next. I think this protocol. Then identifies the IP address of the sending host. I think it is source IP address. Then identifies the priority of each packet. Priority. It is, I think, differential services. Then identifies the IP address to be recipient host. Then it is destination IP address. So commonly referred to a hop count. It is time to leave. Then always set to 01000 for IP version 4. I think the answer will be version. So we are done in this activity. We go to another activity here and answer it. Okay. So this activity. So this activity is entitled IP version for header field. So the instruction is read each IP version 6 header description and then click the IP version 6 header field to which it belongs. So identifies the size of the data portion of the packet. So I think the answer will be payload length. Okay, when this value reaches 0, the sender is notified that the packet was not delivered. Mm, the answer will be hop limit. Then identifies the application type to the upper layer protocol. Identifies the application type. I think that will be next header. Then classify packet to congestion control. So the answer will be low label. Oh my, mali. No, no. Sorry. So classify packet to congestion control. So I think the answer will be traffic class. Then to suggest that all packets receive the same type of handling by IP version per router, then the answer will be low label. Then it's always set to 0110. So the answer will be the version. Okay, we are done to this activity. So we need to find another activity here. Okay, this. So the title of this activity is identify elements of a router routing table entry. So the instruction, so a partial router routing table entry is shown each section of the entry. It is identified by a circle letter above it. Select the correct routing table entry, select for each output. So number 1, so the elapsed time since the network was discovered, then I think the answer will be E. So we need to check it if this is right or correct or wrong. Okay, it is correct. Then number 2, the administrative distance, source and metric to reach the network to reach the remote network. Then I think the answer will be C. Okay. Then number 3, how the network was learned by the router. Then the router. I think the answer will be A. So we need to check it if this is correct or wrong. Okay, it is correct. Then show the destination network. Destination network. Okay, B. So and the answer will be B. Okay, it is correct. Then the number 5, the next hop IP address to reach the remote network. I think it's letter D. So let me check it. Okay, it is correct. Then the ongoing interface on the router to reach the destination network will be the gigabit internet. So it's letter F. Then it is correct. Okay. So we are done in this activity. Okay, we go to here and find another activity. Okay. So the title of this activity is description of the router function and hardware parts. Instruction. Description of the router function and hardware parts are provided in the table. Drag each router component name to its function description. So it will be one interface, AUX port, LAN interface, telnet or SSH, and the console port. So number 1, connect routers to external network usually over a large distance. So I think it is 1 because 1 is wide area network. Okay, we need to check it if it is correct. Okay, it's correct. Then a way to remotely access the CLI across the network interface. So I think it is telnet or SSH because they use the network. Okay, we need to check it if it's correct or wrong. Okay, it is correct. Then connect computer switches and router for internal networking. Wait lang. I think it is console port. Okay. Oh my, no. Connect oh, sorry, I think, sorry. I think the answer will be LAN interface. Then a local port which uses USB or low speed serial connection to manage network devices. So the answer will be console port. Okay, we need to check it if it's correct. Then it's correct. Then a port to manage router using telephone line and modern. So the keyword for this question is the telephone. That's why it is AUX port. Okay, check it. Okay, we are done in this activity. Okay, so next activity is title is the router boot process. So the instruction, so drag each of the step on the left to appropriate field in the table on the right to show the router boots process order. So what is the step 1? I think it the step 1 will be perform post hardware check performed by build in ROM chip. Okay, so we need to check it. Okay, it's correct. Then number step 2, I think it is this step 2. I think the answer will be load bootstrap copied from ROM to RAM locates the IOS. Then the step 3 is load. The answer will be the load the iOS operating system file for the router loaded into RAM. After bootstrap, find the iOS file to be used. And the last and will be the step 4 is load the configuration file from flash and VRAM, a TFTF server or ORGO into setup mode to create a configuration file. Okay, so it is correct. Okay, we are done for this. Okay, I think there's no activity here now. Then we go to chapter 6 conclusion, summary and conclusion. Sorry for the internet. So the conclusion network layer. So the network layer or OSI layer 3 provides service to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses 4 basic processes: the IP address for end devices, the encapsulation, routing, and the de-encapsulation. The Internet is largely based on IP version 4, which is still the most widely used for network layer protocol. An IP version 4 packet contains the IP header and the payload. However, IP version 4 has limited number of unique public IP addresses available. This led to the development of IP version 6. The IP version 6 simplified header offers several advantages over IP version 4, including better routing efficiency, simplified extension header, and capability for per flow processing. Plus, IP version 6 addresses are based on 1028-bit hierarchical addressing as opposed to IP version 4 within 32 bits. This dramatically increases the number of availability IP addresses. In addition to hierarchical addressing, the network layer is also responsible for routing. Host requires a local routing table to ensure that packets are directed to the correct destination network. The local table of a host typically contains the direct connection, the local network route, and the local default route. The local default route is the route to the default gateway. The default gateway is the IP address of a router interface connected to the local network. When a host needs to perform a packet to a destination address that is not on the same network as the host, the packet is sent to the default gateway for further processing. When routers such as the default gateway receive a packet, it examines the destination IP address to determine the destination network. The routing table of a router stores information about directly connected route and remote routes to IP network. If the router has an entry in its routing table for destination network, the router forward the packet. If no routing entry exists, the router may forward the packet to its own default route if one is configured, or it will be drop the packet. Routing table entries can be configured manually on each router to provide static routing, or the routers may communicate route information dynamically between each other using a routing protocol. In order for routers to be reachable, the router interface must be configured. To enable a specific interface, enter interface configuration mode using the interface type and number global configuration mode command. So that's all for this day, and see you in my next video. Bye bye.